Hello, and welcome to your lecture on organic chemistry for functional groups. In this lecture, I strongly recommend that you have a pencil or paper or pen, that you write down questions for clarification, you write down questions about understanding areas, and hopefully when we finish this segment, those questions will be answered. But if not, please make sure that you see your instructor before you take the assessment. In this lecture, we will be looking at functional groups of alcohol, ether, aldehyde, ketone, carboxylic acid, and ester. And we'll be looking at them in groups of two so you can clearly define the difference between them, and that will help you on your way to understanding and recognizing them. The types of functional groups and how they actually look when you see the arrangements of the atoms in the bracelet. There's a few things that first you need to know. Where you see R, it's talking about a carbon in the chain. So let's look at the first one, halocarbon, which you may or may not already know. Halocarbons are fluorine, chlorine, bromine, iodine, and astatine. According to the structure, the halocarbon is attached to any carbon in the chain. So this can be attached to any carbon in the chain. Alcohol is designated by OH, or the hydroxide. And the way this works is we already know that hydrogen only has one bonding spot. That bonding spot is taken up with oxygen. Oxygen, however, has two bonding spots, and that oxygen is able to connect with a carbon in the chain. So alcohol then can be attached to any carbon in the chain. Ether takes that chain and literally splits it. Is it evenly split? Not necessarily. But once it does, these chains no longer are called chains. They are now considered to be charms. Aldehyde has a double bonded O attached to carbon, and it only occurs on the ends. So you have a carbon, double bond to O, attached to the rest of the chain, and then there is only thing left that can go there, a hydrogen. A ketone is a double bonded O attached to the carbon in the chain. Now this is interesting. Notice that the double bonded O of the carbon in the aldehyde looks like the double bonded O of the carbon in the ketone, but notice that the double bonded O to the carbon in the ketone has chains on either side. This tells us, or carbons on either side, this tells us that this cannot be attached to the ends, not the ends. Because if that ketone gets attached to the ends, it's going to look just like that aldehyde. The carboxylic acid has a double bonded oxygen, and it has a bond to hydroxide, or what looks like it could be an alcohol. This is only occurring on the ends. Well, why would it only occur on the ends? Well, a carbon in a chain only has two bonds that it can connect with after it's connected to a carbon. So you'd have to have a bond available so you can have all three bonds, two of which will connect to the oxygen and one can connect to the hydroxide or the OH. And then we have ester. Ester is a double bonded O on the carbon and then a single bond to oxygen on the carbon. The oxygen's other bond goes to the carbon that's in the chain. So ester occurs in the chain. just like ether occurs in the chain. Now, note, both ester and ether break that chain. So ether breaks the chain in the charms, but ester does something interesting. It breaks it into a chain and a charm. And we'll get into that when we actually look at these. Okay? So just be aware, excuse me, of where the functional groups are located in and around the chain. The first functional group we're going to look at is alcohol. Now note that alcohol can be attached to the carbon in the chain at either end. And when it's attached, it's either the chain or the carbon in the chain OH or HO and then the carbon in the chain. How does that look? Well, let me do this just to give you an idea. This would be OH and this would be HO. Now, when we're naming alcohols, you have to remember where that alcohol is located because it can be in any location. Remember, this can be on any carbon. The only exception, you don't need to know the location. It's a methanol, ethanol. Well, why is that? Because methanol only has one carbon to attach alcohol to. And ethanol, if you only have one alcohol, whichever carbon you attach it to is carbon number 1. It is only when it's attached to another carbon, the second carbon, that now you have to get into designating which carbon it's attached to. Also, the name is the last name on the main chain. So here are the rules. You have to have the numbered location of the alcohol charms. You have to have the prefix for the number of carbons in the chain. You have to have the type of bond between the carbons, whether it is an ane, an ene, or an ine. And it has to end in OL. So are you ready? Let's look at our first alcohol. Here is your first alcohol. Here we see the alcohol charm. And of course, because of the alcohol charm, we're going to follow the naming of this. So what do? We look at our carbon chain. We determine where carbon 1 is. Because the functional group charms have priority for numbering, that means that where the alcohol is going to be closest to the carbon number 1 at the end. So this is carbon number 1, 2, 3, 4, 5, 6, 7, and 8. So now we know where our carbon, all our carbons. We know that alcohol is on carbon number 4. We know that fluoro, the halogen charm, is on carbon number 8. We have to name them alphabetically, though. But we know alcohol is the last name of the main charm. Remember, last name main chain. Probably could spell that better, write that better. Last name main chain. So we're going to look at the fluoro. So this is going to be 8 fluoro. And now let's look at where that alcohol is. Alcohol is on carbon number 4. It is an 8 carbon chain, octa. It is single bond, so it's ane. And this says we're going to drop the E from the alkane name. So I'm going to drop the E from the alkane name. And I'm going to add all if I have one alcohol present. I've got one alcohol present. So let's look at what we've done. We have given the last name to the main chain. We have numbered it by priority of the functional group. which is the alcohol. And now that we have our carbons numbered, now we look at the charms, and we have to name the charms in alphabetical order. But since the alcohol is part of the last name, the only one we have to worry about is fluoro. So 8-fluoro. Alcohol is on carbon 4. It is an 8-carbon chain, which is oct. It is a single bond, which is octane. We drop the E from the alkane name, and we replace that with OL because we have one alcohol present. Look at this carefully. Make sure you understand what we've done. Write down whatever questions you have. And then press play and keep going. 8-fluoro, 4-octanol, which is exactly what we named it. Let's look at this one. Again, the alcohol has priority. So this is carbon 1, 2, 3, 4, 5, 6. Now let's look at our charms. We have a bromo here on 1, and we have a bromo on 6, and we have a methyl on 2. So in alphabetical order, this is going to be 1, 6 bromo, 2 methyl, because there's only one, 1. Now let's look at the chain. This is a 6-carbon chain, so this is hex. It is a single bond, so it's hexane. And since there's only one, we're going to have to remove that E. So let's remove that E, and there's only one alcohol, so this is hexanol. So this is 1, 6. Oops, Dr. Hudson, dibromo, because there's 2 of these. So 1, 6 dibromo, 2 methyl, 1 hexanol. Again, 1, 6 dibromo, because there's 2 of those, 2 methyl, 1 hexanol. Let's check. Ooh, Dr. Jones got that wrong. 1,6-dibromo, 2-methyl, 1-hexanol. Go, Dr. Hudson. Ooh, let's look at this one. Okay. We know that this is our chain. We know that the alcohols have priority. The alcohol that's closest to the end is going to be carbon number 1. So carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we now have our chain counted. We have a chloro on carbon 1, a chloro on carbon 3, a methyl on carbon 2. We know that the alcohol is going to be with the last name. So let's look at our charms. Okay. Alphabetically, chloro is before methyl. So this is 1, 3. There are 2 chloros. So this is dichloro. There is 1 methyl. So on carbon 2, you have a methyl. And then look at your alcohols. You have on carbon 1 and carbon 7, 1, 7. This is a 10-carbon chain, which is dec. It is single bond, which is decane. And because we said that if there's more than one, we leave the E on. So we're not taking that E off this time. So it's decane. And there are two alcohols. That's di, and it ends in all. So this is 1,3-dichloro, 2-methyl, 1,7-decane diol. Again, why did I leave that E on there? Because that E is only taken off if there's a single alcohol. So we're going to put down remove E from alkane only with one alcohol. Maybe you'll remember it better that way. So let's check ourselves and see if Dr. Hudson got this right. Dr. Hudson got this wrong. 1,3-dichloro, 2-methyl, 1,7-decane diol. Hope you're feeling good. Let's look and see if we got more to do. Oh, here's another one. Why don't you pause the video here and see if you can do it yourself and come back and check. So, here is our chain. We're looking for our alcohol that's closest to the end. Well, we've got two alcohols closest to the end. Uh-oh, what do we do? Well, according to priority now, we look for the end that has the most charms closest to it. Oh, that's cool, because this side has two charms closest to it, and this side has two charms close to it. Well, that's not going to work. So then we continue to look. Well, what else do we have? Oh, we have another charm. It's a little up, but still, this side is charm heavy, whereas there's nothing here. So we're going to use the side that has the alcohol, the bromo, and the methyl, because that's charm heavy. So this is carbon 1, 2, 3, 4, 5, 6, and 7. And now let's look at our charms other than alcohol. We have a bromo on 7, a bromo on 1, and we have a methyl on 2. Alphabetically, bromo goes first. So this would be 1, 7. There's two bromos, so di, bromo. On carbon 2, we have a methyl, so 2, methyl. And then we look at our alcohols. Well, on carbon 1, carbon 4, and carbon 7, we have alcohols. It is a 7-carbon compound, so it's hept chain, and it's single bond, so it's A-N-E. Am I going to keep that E or get rid of that E? Well, there's more than one alcohol, so I'm going to leave this E right here. And there are 3 alcohols, so that's going to be tri, and we said it's got to end in all. So this looks like 1,7-dibromo, 2-methyl, 1,4,7-heptane triol. So let's check ourselves. 1,7-dibromo, 2-methyl, 1,4,7-heptane triol. Good job. Good job. Okay, so we've named this correctly. Let me make a note right here that your naming, and I don't know if they've gone through this already, but your naming of compounds, there is a comma between the carbons that both have the same charm. There is a dash between the carbon and the name of the charm, and a dash between each one of those charms and the carbon and the name of the charm. But the name themselves do not have dashes between them. And I'm sure your instructor has already explained that to you. Okay. Ooh, here's one. Want to pause that and come back to it? So here's our chain. Priority to the alcohol. Well, this alcohol is close to carbon 1, but so is this one. So that's not going to work. So then we look for charm heavy. Well, these are kind of charm heavy because this only has one connected to it. So we're going to go for carbon number 1 being at the top here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now let's look at our charms. We have a methyl. We have an ethyl. We have a bromo and another bromo. We have a chloro, and good Lord, we have a propyl. So alphabetically, who goes first? I'm going for bromo. So like 1,10 dibromo, right? And then chloro, 1 chloro, and then ethyl, 4 ethyl, methyl, 4 methyl. We'll look at this in a minute. Make sure we have it alphabetically right. 7 propyl. And let's look at where our alcohols are. 2, 3, 6, 9, 10 carbon, chain, dec, single bond, decane, more than one alcohol, leaving the E. And there are 4 of these alcohol. Tetra, all. So 1,10 dibromo, 1 chloro, 4 ethyl, 4 methyl, 7 propyl, 2, 3, 6, 9 decane tetra all. Let's test and see if we got that right. Woo. So let's see how well we did. 1,10 dibromo, 1 chloro, 4 ethyl, 4 methyl, 7 propyl, 2, 3, 6, 9 decane tetra all. Good job. So let's look at this. This is a cyclohydrocarbon. And with the cyclohydrocarbon, we know that it is simply, there's 3 carbons, 1, 2, 3. So we know it's propane because it's a single bond between the carbons and it is connected, so it is a cyclopropane. Okay, so now let's look at where our alcohols are located. Well, we have an alcohol on carbon 1, carbon 2, and carbon 3. And this is cyclo, because that's the name of it. Propane, because it's a single bond. Right? And there's an E on the end because there's more than one alcohol. And there are tri, because there's 3 of them. And it is all. So this would be 1, 2, 3, cyclopropane triol. So let's test yourself, see how you did on there. 1, 2, 3, cyclopropane triol. Excellent. Good job. Very good job. All right, so now let's talk about ethers. Ether is an oxygen that literally splits the chain into 2 charms. Remember I talked earlier about 2 charms. All you're going to do is you're going to name each charm like you would a normal charm with a YL, alphabetically, of course, and then you're going to add the word ether at the end of the name. That's how you're going to name this. Okay? So, are you ready? Let's go ahead and do this. So here we have the ether that cuts that chain into two charms. And when we look at the two charms, we have a propyl charm, we have a butyl charm. Alphabetically, butyl comes first. So this is butyl, propyl, and of course, ether. Okay? Because what did our rules say? We split the chain into two charms. We name each charm, and we put ether at the end. So, butyl, propyl, ether. What about this one? This is our ether. Breaks it into two charms. This charm is methyl. This charm is propyl. Alphabetically, methyl comes before propyl. So this is methyl, propyl, ether. Here we have our ether. This is ethyl, and this is a 7-carbon charm of heptyl. Ethyl comes before heptyl, so this is called ethyl, heptyl, ether. See if you can figure this one out. It's got a little twist. This is our ether. This is pentyl. This is pentyl. There are two of them, so this actually is going to be called dipentyl ether. Ooh, this one's interesting. Now, let's do this together. Here's your ethyl. This is methyl. This is propyl, but that carbon is connected in the center. So it is 2-propyl, or what they call isopropyl. So this then is going to be called methyl 2-propyl ether, or methyl isopropyl ether. Either name. What about this one? 2 ethyls, diethyl ether. If you're getting this right, you're doing just fine. Look at this one. Oh, wow. Okay. We know this is ethyl. This is cyclopropane, but it's a charm, pentyl. And this, of course, is ethyl. So that alphabetically, it's going to be ethyl cyclopentyl ether. Ethyl cyclopentyl ether. You're going to pause here, and that ends your lecture. Have a great day.